Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to start the chapter on exponential and logarithmic functions. This is awesome, guys. I'm so proud of you. Usually I don't have time to do this with a regular algebra class. That's why this is Algebra 1 and 2. So you guys are learning some good stuff today. Composite function and inverse functions. Before I get to the composite function, I want to have just a little bit of a review on function operations. Let's remember that a function, okay, is any relation. Remember, a relation is just a set of ordered pairs, okay? Just a set of ordered pairs is any relation where there can be only one y value. Remember that y is a dependent variable for any given x value, the independent variable. That makes sense, right, guys? You remember that? Okay. Please remember also that the symbol f of x represents the dependent variable y. F of x equals y. Why do they change it, Mauro? Because it's called function notation. It's a little fancier, basically. But f of x does equal y, okay? The whole value, this whole f of x, is the same thing as saying y. You read f of x as f of x. Please remember what it means. It means function f with independent variable x. That's all it means. So if I give you h of k, that means, oh, okay, this is function h with independent variable k. Does that make sense, guys? Okay, this is all should be pretty clear in your brains, right? Okay, let's just go through some operations. I want to make sure that you guys are sharp on top of this. If I say f of negative 2, what am I replacing the x with, my friends? So this is 2 times negative 2 minus 3, so that's going to equal negative 7. Done. If I'm replacing x with, I messed up. What am I replacing x with in this case? W. So I'm going to go 2 times w this time minus 3. Done. This is just evaluating a function. If I give you a function and I tell you evaluate f of blank, you plug in that blank, whatever it is, into every single x value of the function. Okay? That makes sense? You guys remember that? Okay. That's why I'm going kind of fast. Please slow me down if you need me to slow down. As far as the function operations go, my friends, please remember f plus g of x means f of x plus g of x. That's what that means. We're going to have examples now in a second. F minus g of x means take the function f of x and subtract it from the function g of x. Okay? When I have f of g of x, f times g of x, it's f of x times g of x. If I have f over g of x, that means I have f of x divided by g of x. G of x cannot equal 0, as we all know very clearly. 0 in the denominator means that it's undefined. Okay? Does that make sense? Okay. May I continue? Okay. So for example, let f of x be 3x squared plus 2 and let g of x be x minus 5. Let's go through some function operations, please. Find f plus g. Actually, technically, I should have put here, I'm sorry. Find f of g of x. Find f minus g of x. So let's find f plus g of x. Well, this is f of x plus g of x. Combine like terms. This would be 3x squared plus x minus 3. Done. Nice and easy. F minus g of x. Okay. F of x, which is 3x squared plus 2, minus parentheses g of x, which is x minus 5. Please remember that you are subtracting the value of g of x. So that means you have to distribute that negative. Please remember that. So I've got 3x squared plus 2 minus x plus 5. So f minus g of x is going to equal 3x squared minus x plus 7. Not too hard, not too complicated, but very important nonetheless. Okay, guys, so this, again, please, is this ringing a bell for everybody? Okay, thank you. Now, f of x equals x squared minus 4 and g of x equals x plus 2. I want to find, again, I technically wrote this inaccurately, I'm sorry. It's f times g of x. Sorry about that. I want to find f times g of x. Well, in this case, it's going to be x squared minus 4 times g of x, which is x plus 2. All of these skills you know how to do. FOIL, x cubed plus 2x squared minus 4x minus 8. It's already in standard form. Ping, pong, boom, done. That makes sense, my friends. And last but not least, find, again, I wrote this inaccurately, I apologize, f divided by g of x. So it's going to be x squared minus 4 over x plus 2. Well, we know how to do this already, if possible. Factor, man. So we got x plus 2 times x minus 2 over x plus 2. Boom. And I got x minus 2. Or I could have done synthetic division if I wanted to as well. Okay. And just to go over it just real quick, synthetic division, if you remember, you put the root, so that'd be negative 2. Okay. And then you put all of the coefficients without skipping any. So x squared, 0 for x, and a 9 and a minus 4. You drop down that 1. 1 times negative 2 is negative 2. 0 minus 2 is negative 2. Negative 2 times negative 2 is 4. That's 0. So now I started with an x squared, correct? So now I drop 1. So this becomes x minus 2. So either way, this was actually a great question because it gives you a little review of synthetic division. All right, so that's pretty cool. Does that make sense, boys? All right, let's learn what we actually have to learn today. All of that was old stuff. Okay, now, today we're going to do composite functions. The good news, if that was easy for you guys, which by your faces it seemed pretty easy, this is going to be a joke. Composite functions, please look at the symbol. That is not a time symbol. It's literally an open circle. Okay? What this is saying is this. F of g of x. F of g of x. So what am I replacing the x with in the function f? The whole entire g of x. Or g of f of x. G of f of x. What am I replacing the x in the g function with? The whole entire function f of x. So I call this fog or goth. I don't know why, it's kind of weird, but yes, fog or goth. Do not multiply those, okay, my friends? Please be careful. When it's an open circle, it will always be an open circle. Don't think, oh, Mr. Moore, are they going to fill it in and try to trick us? No. No. It's not, think about it. F of g of x. What did I replace the x of function f with? The whole entire function g of x. We're gonna practice it now, I promise. Sir, my brother. No, you do not multiply the g of x. No. Let me teach it before you guys go crazy. Okay. I got f of g of x. F of g of x. I want to evaluate, what you do is you first evaluate g of x, and then you evaluate f of x, okay? I want to find g of f of negative 4. G of f of negative 4. So what I really have here is this. G of f of negative 4. Look at what I'm doing. What am I replacing the g with? I'm sorry, that was a stupid question. What am I replacing the x of function g with? F of negative 4, right? So I should have reversed these, guys. I goofed up. For this particular question. Actually, no. If it depends how, I don't know why I did it like this. Yeah, it depends on what I did. If it was like this, yes, you evaluate g of x first. Then you evaluate the f of x. But in this case, I have g of f of negative 4. So I'm going to first evaluate f of negative 4. F of negative 4 is negative 9, right, guys? So now I have g of negative 9. So now I plug that in. G of negative 9 is going to equal 81. Tell me that was hard. Talk to me. That's why I'm here. Okay. Let's just do it again. Thank you, my brother. It's okay. It's okay. We're gonna figure it out. This is g of f of negative 4. So what am I replacing every x in function g with? The value of f of negative 4, right? So let's find f of negative 4. Step 1. You're going to find the interior one first. So that's going to be negative 4 minus 5, which is negative 9. Now step 2, evaluate the exterior. G of negative 9 equals negative 9 squared. Because x is being squared. The value of x here is negative 9. So g of negative 9 equals 81. Thank you, my brother. How about this one, guys? F of g of negative 2. F of g of negative 2. What do I have to find first? G of negative 2, which is, so g of negative 2 is 4. Now I have to find f of 4, which is going to be negative 1. Does that make sense? Sure, my brother. They're going to be a little bit more complicated. I think I have some more examples now. Do I? No, I don't. Okay, let me do this. Let's do a nasty one. Let's do f of x equals, okay, I'm going to do two ways. X squared plus 5 and g of x equals x minus 2. I want you to find f of g of x and g of f of x. Okay, what am I replacing for this guy? Actually, I should have done this in a different color. Let's stick to green and f of g of x. What am I replacing every x of function f with? G of x, right? What is g of x? X minus 2, right? So f of g of x is going to equal x minus 2 squared. Why did I do that? Didn't I replace the function of g of x into the x of f? Did you see that? Plus 5. Now, FOIL. That's x squared minus 4x plus 4 plus 5. So that equals x squared minus 4x plus 9. Does that make sense? That's why I'm here. That's why I'm asking. I'm waiting. Talk to me. Sir. Okay, thank you very much. F of x is x squared plus 5, right? What did I replace the x of function f with? G of x, which is x minus 2. So I plugged x minus 2 into the x. Does that help? Thank you. Sir. If you can factor this one, you can. Yeah, go for it. But you can leave it like that as well. Thank you, my brother. Now let's try in red g of f of x. What am I replacing the x in function g with? So I'm going to have x squared plus 5 minus 2. So that equals x squared plus 3. Why, Moro? What did you do there? Well, I took the x squared plus 5, which is the new x of function g, and I plugged it into the x value. Does that make sense, guys? Because I'll explain it again if you need. You got it? Good, good. May I continue? Okay, thank you, guys. Now, inverse relations and functions. Okay. Before I really start talking about inverse functions, I did want to talk to you about one thing called a one-to-one function. Okay? A one-to-one function. We know that that's a function because I have vertical line tests, and for any x value I have one y. Right? You guys with me there, right? Okay. That's a function. Now, a one-to-one function is a little bit different. A one-to-one function is the reverse. Okay? This is a function where x is the independent variable. A one-to-one function by definition is not a function where x is independent. It's a function where y is independent. Okay? Y is independent. What am I talking about? If I have a graph, and let's say, for example, and actually, wait. Okay, let's scratch what I just said. Scratch that. I'm thinking of something else. I'm sorry. Had a little bit of brain amnesia. We are still talking about one-to-one functions. But a one-to-one function is something like this. Let's say that I have a cubic function. Okay? When we did a vertical line test, that determined if it was just a pure function. We're going to now do what's called a horizontal line test to see if it's a one-to-one function. So when I do a horizontal line test, I'm going through the y's. And what I'm checking for is to make sure that any y value only came from one particular x value. So at this y value, I only hit the x once. At this y value, I hit the x once. At this y value, I hit the x once. At this y value, I hit the x once. Since at every one y value, I hit one x, it's a one-to-one function. Yes, sir. I'm going right now. I haven't done all of them. Give me 1 second, please. Yes, sir.
How, like a straight line?
A straight line. Yes, very good question. His question was, what if I have something like this? That's an x equals equation. It's not a function, but it is a one-to-one function. Because at every one y, there is only one particular x. Yes, sir. Hold on. If you let me continue, guys, I will answer all of your questions. Let me teach and then answer. And then I'll answer their questions. Thank you, though, for your motivation, guys, and your wanting to learn. It really means a lot to me. Okay. Let's say I have this. A parabola, as someone had asked me. Is this a function? Yes. Is it a one-to-one function? No. Because at this particular y, I go through two x's. At this particular y, I go through two x's. At this particular y, I go through two x's. So this would be a 1 to 2. This would not work. What if I had a graph like this? Is that a function? Yes, because there's a vertical line test makes it a function. I only have one y for any one given x. But if I go horizontal line test, is it a one-to-one function? No, you're hitting at three different x's. Okay? Oh, I thought I saw a hand up there. Okay? You can also recognize one-to-one functions by tables. Say I have the following, whatever. 2, 3, 4, 5, 6. But I have here a 5 and a 5 and then an 8, 9, and an 11. I have the same y value being produced by two different input values. So when I have the same y value being produced by two different x values, that is not a one-to-one anymore. In order for it to be a one-to-one, one y value only corresponds to one x value. Okay? Does that make sense? Okay. Now, why do we even learn this? Because what we did here is we went from a vertical line test to a horizontal line test. This is the beginnings of what's called an inverse function. When we talk about an inverse relation or function, inverse, we are simply switching all of the domain values, all of the x values, with all of the relation values, all of the y values. In other words, you must switch all x's and y's. And that's wrong. This word should not be relation values. It doesn't even exist. It should have range values. Sorry. Okay, so how do you work this? How do you make an inverse? Guys, this is, believe it or not, a long lesson, but the easiest lesson you're going to learn this year. See how I have x, y? Switch them, dude. Put the 3 where the x is and the 2 where the y is. 3, 5, the inverse is 5, 3. 4, 7, the inverse is 7, 4. 2, 6, the inverse is 6, 2. It's literally that easy. Literally. I'm laughing because someone just said they didn't get it. That's funny. Okay. Now, they'll give you a table and they'll say, find the inverse of the given relation. A lot of people stress out. That's just because they haven't been taught. My friends, switch all of the y's literally to where the x's are, and all the x's to where the y's are. So my inverse relation will be 5, negative 2, 4, negative 1, 3, 0, negative 4, 1, and negative 5, 2. Now, Mr. Morrow, this is all great. So what? Let me show you what happens when you graph these two different functions. I got negative 2, 5. I'll do this in blue. Negative 1, 4. 0, 3. 1, 1. Negative 4. And 2, negative 5. So this guy goes like this. Now, let's graph the inverse with green. 5, negative 2. 1, 2, 3, 4, 5, negative 2. 4, negative 1. 3, 0. Negative 4, 1. And negative 5, 2. It's literally the inverse. We don't say opposite. We say inverse. No need to apologize. I'm just trying to get your vocabulary, your vernacular correct. So that's all we're doing, guys. When you're inversing something, you're switching the x for the y's. Mickey Mouse, right? Okay. More Mickey Mouse. More. Finding the inverse of an equation is just as easy, I promise. Simply replace the x with the f of x or y, depending on what they tell you. And then solve for y. Literally. Make this y an x. Make that x a y squared. Now solve for y. So add 2 to both sides. I got y squared equals x plus 2. We know how to solve radicals. Y equals plus or minus square root of x plus 2. I kid you not. That is the inverse of that. Literally, replace the x with the y and the y with the x and solve for y. Literally. What are the graphs of y equals 3x minus 5 and its inverse? Okay. Let's first find its inverse, huh? Let's replace that y with an x and that x with a y. And now let's solve for y. So add 5, x plus 5 equals 3y divided by 3. Y equals x over 3 plus 5/3. They want us to graph both that and the inverse. So let's do it. Y equals mx plus b. So negative 5, 1, 2, 3, 4, 5. My slope is 3. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Down 1, 2, 3 over 1. That's my original line. And my inverse, 5/3, that's 1 and 2/3, so a little bit under 2. I'm estimating that y-intercept. And then from there, I'm going to go up 1 over 3. So up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Down 1 over 1, 2, 3. That's the inverse, my friends. Does that make sense? Pretty simple, right? Pretty easy. It's using equation skills that we've already learned. Find the inverse of f of x equals the square root of x minus 5. Replace the f of x with x and replace the x with y. Now solve for y. Square both sides. I got x squared equals y minus 5. Add 5 to both sides. Y equals x squared plus 5. Bam. Talk to me. Talk to me. I'm here. Whatever you guys need. Yeah, that's it. So we're done. So talk to me. Any questions before I close out? Thank you, guys. Hope you learned a lot. Have a great day. Thank you out there in the internet world as well.